Hello, everyone, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. Now I would like to introduce today's presenters. With us today, we have Joy Deep Sanyal. Joy is the Product Line Manager for Circular and Rectangular Metal Connectors at Smiths Interconnect. Also with us today is Giacomo Gennari. Giacomo is the Design Engineer for Defense Space Aerospace Connectors at Smiths Interconnect. To read more about either presenter today, go ahead and look at that speaker bio window right next to the main presentation window. So now I'm going to talk about some of the things on our agenda today. First, we're going to highlight the current market situation. We're going to showcase how Smiths Interconnect can provide a groundbreaking solution to the growing battery systems market. And we're going to give some insights on our solution and what advantages it brings. Then we will have a short Q&A session at the end. So with that, I am going to pass things over to Joy to get us started for today. So Joy, go right ahead.
Thank you, Katie. Good morning, good afternoon, good evening from whichever part of the world you have joined. Thank you for taking the time to join this webinar. As the world experiences, if you like, a monumental shift on a scale that has not been seen in a century, transitioning from fossil fuel engines to electric power, I suppose the importance of batteries, they've risen to the forefront of design across a wide range of systems. This has resulted in battery packs becoming central to supporting electrification and therefore contributing to the bigger objectives like the energy transition and net zero. You see, recent advancements in battery technology have led to the use of battery packs in several end-use applications. For example, off-road vehicles in mining, construction, defense applications, locomotives, just to name a few, right? There are many more out there. They are all showing promising developments in the use of battery packs. With electric power, vehicles such as the ones that I talked about can achieve instant torque, providing better control and power management, which is particularly beneficial in off-road and arduous environments. Additionally, the removal of traditional engines or reducing the size of the traditional engines can lead to reimagining the vehicle architecture, offering more space for cargo or other equipment. Now you see, connectors are, in any of these use cases we want to talk about, connectors are integral part to a battery pack system design. And whether we like it or not, unfortunately, they come with their own set of challenges. The physical design of connectors is often an area of focus for many end-use applications. Space constraints within battery packs demand compact and flexible connector systems that can accommodate various configurations depending on the vehicle's energy and capacity requirements. However, when one zeroes in or focuses in the power connectors particularly, we have seen multiple challenges, particularly within the socket design, resulting in power loss, particularly due to high contact resistance and temperature rise. At Smiths, our approach to solving problems like these is through the lens of total cost of ownership. Now, total cost of ownership, whether we like it or not, sometimes is a bit of a cliche. In many discussions with customers, I see this word getting used or this phrase getting used. However, when we delve deep into this, we see that in this equation, many users focus on the initial purchase cost, the cost of installation, and more often than one thinks, the cost of not operating or poorly operating, the last box on the bottom right that you see here, the cost of not operating or poorly operating is overlooked. It's a sad reality, but it's a fact, because often it is difficult to quantify what is that cost of not operating or poorly operating because of a connector. So in this webinar, we will try to explain the consequences to a system's design and inefficiency due to poor or poorly operating connectors. Now, joule heating in power connectors is a critical factor to consider when designing battery packs. It is the heat generated by the resistance to the flow of electric current within the connectors that can affect the performance and safety of the battery pack. This heat needs to be managed effectively to prevent overheating and ensure longevity of the battery pack. Now, understanding and controlling joule heating is essential for efficient operation of the battery packs, especially in high power application. If one examines many of the connectors available in the market for battery applications, you will see, if you really focus on the connector, power connector, you will see the conducting contact area. I mean, in a conventional pin and socket pair, the part that is actively in contact with each other is in that area, only a certain point across the overall contact area, they are in touch with each other. These points of contacts or a reduction in contact area will result in constriction current at those contact points. Now, the constriction current produces joule heating and increase in local temperature. The higher the electrical contact resistance, the higher the level of contact overheating and therefore unwanted power loss. And that power loss ultimately defeats the overall objective from a design perspective for which we are putting batteries in the first place, and it creates inefficient system design and operation. Now with that, before I move further, I would hand back to Katie to run a quick poll question before we talk about how Smiths can solve one of this engineering conundrum in future. Over to you, Katie.
All right, thank you so much, Joy. So we have a polling question for all of you. So the question is, in your experience in applications requiring high current connectors, how important is it to have connectors with low contact resistance and low temperature rise? So we have three options here. We have A, which is important, B, somewhat important, and C, not important. So I'm going to leave this polling question right up on the screen for you all for about 30 seconds. If everyone would enter in their response, your feedback is always important to us. So I'll read through the question one more time. In your experience in applications requiring high current connectors, how important is it to have connectors with low contact resistance and low temperature rise? Again, our options are important, somewhat important, and not important. So I'll leave this up for about 10 more seconds so we can get most of you in here to answer. All right, thank you for everybody that's responding. We appreciate your feedback. All right, Joy, I'm just going to leave it up there for about 5 more seconds, get a couple more answers, and then we will share our polling results.
Sure. Thanks.
All right, thank you everybody who has responded. Joy, I'm going to push us over to the results slide now so we can see what everybody is thinking. All right, and here are our results. So Joy, I'll pass it back to you.
Thank you, Katie. I suppose the results is a reflection of exactly what we have found in our experience dealing with high power connectors, that contact resistance and temperature rise are two sides of the same coin from an engineering challenge standpoint. And to ensure there is a good design, they both have to be tackled. And as I said, they are two sides of the same coin. So if you address one of them, by definition, you're also tackling or mitigating the other. So with that, let me move on to how we in Smiths can solve this engineering conundrum. So we are absolutely resolute in solving this problem, as we see power loss as defeating the core objective for which one wants to introduce batteries in their systems. We are therefore, as a team, hugely proud in launching today the Hypertac Green Connect contact technology that I will take you through in quite some level of detail as to what the features, benefits, and value proposition of the contact is. But before I do that, let us go through a short video to look at the contact, and then we can delve deep into it. Right. So let's do a little bit of deep dive into what this contact technology is, how is this different, and what's new about it. So Hypertac Green Connect has been designed with materials that are not only fully compliant to REACH and ROCH, but uses no substance of very high concern or even beryllium. Now, this is a huge step forward in terms of innovation in materials science research by our team, which I hope the industry would greatly welcome and applaud the achievement of this innovation that we are introducing today. The contact has been designed with the hyperboloid technology, a technology where the position and angles of the wires are in a hyperboloid geometry surrounding the meeting pin. Now each wire wraps around itself around the pin, providing lines of contact along the pin, as opposed to a few discrete points of contacts, as I was mentioning in the previous slide, which is the origin of the problem or the challenge with the engineering challenge with other connectors available in the market, that they are the point of contacts are in discrete points, which creates overheating and therefore the power loss. Now the collateral benefit of this is that the male pin also acts as a heat sink to keep the wires cool. It extends the whole length to prevent wires from overheating and higher power contacts. So the Hypertac Green Connect contact that we're introducing today has been designed for a high current carrying capacity capable of up to 90% more energy transfer at 500 amps overload mode condition. And I repeat this, up to 90% more energy transfer. This is a staggeringly big amount of energy transfer that this contact is able to achieve. And even a bigger achievement of this is that we are able to do this even after 10,000 insertion and withdrawal cycles. Now, in many applications, you would think that you may not need 10,000 insertion withdrawal cycles. You may be needing only 100 or a few hundred at max. But remember, the point we're trying to demonstrate by saying even after 10,000 mating insertion withdrawal cycle is to demonstrate the reliability of technology to perform with, for years to come in an arduous environment. The low contact resistance reduces the heat buildup, allowing the contacts able to handle far greater current in smaller contact assemblies without adversely affecting the temperature rise. Because just remember what I said in the previous slide, that the contact resistance and temperature rise are two sides of the same coin. Now, we at Smiths as a team, we have gone further, being absolutely resolute in solving this engineering challenge in reducing power loss. We are not only proud to introduce this contact technology with hyperboloid technology within it, with looking into new materials to take away any form of substance of very high concern or beryllium within it. We are also very proud to introduce an additional innovative feature, which is patent pending in the chrome barrel area. Now, this additional feature will further reduce the contact resistance, making it even easier, or from a performance standpoint, better for high power contact or high power applications. Finally, we have gone ahead and tested this technology up to 40,000 or 240,000 mating cycles. And again, this is not necessarily that one needs 40,000 insertion withdrawal cycles in an application like this always. There are some applications that does require in tens of thousands of insertion withdrawal cycles, but this is more as a testament to the robust design for arduous applications and delivering towards our goal for the lowest total life cycle cost. Because just to remind ourselves, one of the things I said, it's often very difficult and therefore sadly overlooked. What is the cost of a poorly performing or a not optimally performing connector? And that's the reason we have tested it to its limit to see how well the heart of the product performs. Let us spend a bit of time on the innovation around the material science, which as I said earlier, I hope the industry would greatly welcome and applaud the achievement that the team has managed to achieve. Now, the contact body is made from a highly conductive copper alloy, which is roughly around 90% to 90% IECS or International Annealed Copper Standard. This will deliver superior conductivity performance compared to often what you have available in the market, which is a free machining brass, which is approximately 25% IECS. Further, because hyperboloid technology use wires, the socket wires of the hyperboloid cage is made from a highly conductive novel material, which is our innovation, if you like, approximately using 55% IECS. Superior conductivity performance compared to beryllium copper, which is roughly around 25% IECS, and phosphor bronze, which is roughly 15% IECS. So as you can see, we have taken the time to understand and look at every single element that make up the product to ensure we are not only delivering a superior performing contact technology for power connectors, but we are also taking care from an innovation standpoint materials that are free from any form of either sunset date or substance of very high concern. And as I said, some of the patents are pending and I hope the industry will applaud some of these achievements from the team from a material science innovation standpoint. With that, I will, as engineers, we all love to understand numbers and results. So with that, I will hand over to Giacomo to take us through some of the results. Over to Giacomo.
Thank you for the introduction, Joydeep. Moving to the test results, here we have a summary of the contact resistance results. The test was performed applying 100 amps and measuring the voltage drop between pin and socket. We obtain the behavior of the contact resistance during all the product life, repeating the test at each mating cycle step from 0 up to 40,000 cycles. Within the chart, we can find all contact tested. Blue for the new silver-plated Hypertac Green Connect socket, orange for the standard gold-plated Hypertac socket, dark gray and light gray for the two manufacturers considered for the benchmark testing. The diameter of the contacts tested is 8 mm, crimped on a 70 square millimeter cable. Smiths Interconnect contacts design demonstrated a superior contact resistance performance with a stable behavior along all the product life, particularly using the new silver-plated Hypertac Green Connect socket, where the test was performed up to 40,000 mating cycles. Focusing on the two other manufacturers, the contact resistance already started to increase between 0 and 100 cycles, and the test was stopped at 10,000 cycles due to wear that did not guarantee a stable contact. Moving to the next test results, here we have the graph of the temperature rise at 250 amps, measured by the difference between the temperature reached by the contact and the ambient temperature. As previously, the silver-plated Hypertac Green Connect socket shows the lowest temperature rise due to the lowest contact resistance. This is ensured by the high number of contact points and the high conductivity of the new wire material used inside. In addition, the development of the new crimp termination allowed us to lower the heat generated in the connection between the cable and the socket. In conclusion, with this new solution, we can carry more current without increasing the size of cable or sockets. The last test results we present is the overload mode test that measures the energy that the contact can transmit at 500 amps and 1000 volts, with a temperature rise limited to 50 Celsius degrees. As seen before, both Hypertac solution, the standard one and the new Green Connect socket, can transmit a higher amount of energy, dissipating in joules heat only a limited amount of energy. The last point to highlight is the stable performance of the Hypertac Green Connect socket along all the product life from 0 up to 40,000 mating cycle. Thank you for the attention. I let Joy continue the presentation.
Thank you, Giacomo. So just to summarize through those graphs, as you saw, we have done extensive long-term testing against our existing portfolio of technology as well as some of the peers available in the market today. And from this extensive kind of experiments and tests, we are able to conclude with the Hypertac Green Connect, we are able to transfer up to 90% more energy in overload conditions. Overload meaning that for a period of time, if you need, shall we say, additional amount of current. So if a connector is operating at 300 amps, but wants to kind of for a period of time wants 500 amps, then that is what overload is. So we have results to demonstrate we have got up to 90% more energy transfer. And secondly, I come back to that burning question that we started our discussion with, that what is that cost of poorly operating or not operating a poorly performing connector? And in our calculation, we have arrived to this value that you would be able to save up to 50% cost due to using less energy per connector. And that the way we arrive to that calculation is based on using a connector on a standard heavy-duty construction equipment working 8 hours a day for 6 days a week over 8 years at a energy cost of what is currently in the UK at 20 cents per kilowatt hour. So that is what, and again, a 50% cost savings at purely down to the contact is again a staggeringly big amount one needs to consider when making design consideration for a contact or a connected technology for battery applications and high power applications. With that, I will switch over to a couple of success stories. Now, I would say that those success stories are not with Hypertac Green Connect, but they are with our previous generation of hyperboloid contact. But given that the Hypertac Green Connect has been kind of designed from a baseline of already a very premium contact technology, one would expect that those success stories to only become bigger and better in future when someone uses Hypertac Green Connect. So here's an example of a Japanese electric vehicle manufacturer who was looking for a high reliability, high power modular connector for battery systems of a pioneering electric car at the beginning of 2000. So it's quite a way back. Now, the way the requirements that they were looking at that time was to overcome the technical challenges of a high power in their new battery charging system. Now, what we proposed to them was a heavy duty modular connector with the high power contacts, which is a 200 amps. Now, the reason they kind of looked around the market and ultimately designed in the Smiths solution is because it ensured smooth and easy mating cycles with low insertion extraction forces. It had low contact resistance, avoiding overheating and power loss, which is, as I said, the crux of the problem really within power contacts or power connectors. Long lifetime until replacements required. And again, with the Hypertac Green Connect, if you kind of bring us forward in 2024, as I said, the reason Giacomo talked about 40,000 mating cycles of testing is not necessarily many of these applications will require 40,000, but this is a testament of the product's design of how long it can last, and therefore coming back to that equation of lowest total ownership cost. Easy handling by the end user, high reliability from a battery charging system, and again, it's good to proudly associate ourselves with a ultimate product, which the EV car that you see on the top left, which does look quite a bit different from a standard car, one has to say, reached a record speed of 375 kilometers per hour in 2005, So again, a big achievement for the designers who designed that car. But from our perspective, we take solace in the fact that we had a contribution in helping the design team with a critical connection point, interconnect point, for which that the speed, I'm sure, would be kind of relying on. The second success story is, again, going back to our hyperboloid technology. An European racing car manufacturer was looking for a high reliability contact for a battery charger for a new racing car. They were looking to overcome some of the technical challenges with the high power in their new battery charging system. Now, the solution that we offered them is with a special range of custom design high power hyperboloid socket at 300 amps. And the reason they looked through in many different available solutions in the market and ultimately settled with the Smiths design is because it gave them that smooth insertion extraction meeting cycles with no forces, low contact resistance, avoiding overheating and power loss. As I said, that is the center's kind of problems that everyone's have been trying to solve. Long lifetime under replacements required, easy handling by the end user, and finally high reliability of the battery charging system. So again, two success stories from our previous generation, but with Hypertac Green Connect kind of going over and beyond what the premium hyperboloid contacts anyway able to deliver. We are quite confident that it would solve some of these big engineering conundrums in battery applications, and will ultimately kind of help the industry to progress in delivering its part in this, bigger objectives that we all are kind of trying to somehow contribute towards energy transition and net zero. With that, I pass it back over to Katie for any Q&A. Thank you.
All right. Thank you so much, Joydeep and Giacomo, for that great presentation. So we are going to move into taking a couple questions from our audience members at this time. The first one is asking, what allows Smiths Interconnect technology to perform better than what is currently on the market?
I can take this question, Katie. So thank you for the question. The hyperboloid contact technology uses a set of socket wires properly angled to form a hyperboloid shape and elastic conductive sleeve. When the mating pin enters the socket, the sleeve expands all around it, providing many lines of electrical contact at not only few points of contact, allowing the current to flow through a large contact surface area. In addition of a standard hyperboloid solution, this new Hypertac Green Connect socket provides superior electrical performance, replacing the standard beryllium copper wire with a more conductive silver-plated copper alloy material, and increasing the number of wires up to 36, for example, for the 8 mm diameter socket. Another hyperboloid socket advantage is the excellent mating durability performance, as the hyperboloid shaped socket wires suffers a limited mechanical wear respect to a standard slot or stamped contact technology. All
right, thank you so much for that answer, Giacomo. All All right, our next question here today. Does your company offer the possibility of customizing the contact design?
I can take this question again, Katie. So yes, Smiths Interconnect offers a standard contact design within the Hyper series catalog, but the hyperbolic contact can be customized to meet all customer requirements. There is no limit to design customization, and as we can accommodate different termination size and style, and add other mechanical feature to fit the existing connector or to develop a brand new solution. Today, we are presenting the 8mm diameter contact, but Smiths Interconnect has the capability and the capacity to develop and produce contacts in smaller or larger sizes and volumes.
All right, thank you so much for that answer. All right, gentlemen, next question here. What are the other target markets applicable for this new high power contact?
So I'll take that one. So I did touch upon a few, for example, off-road vehicles in mining, construction, defense, locomotives, just to name a few. But there are, of course, there is a lot many other applications where power requirements are increasing with every next generation of their design. Again, one that springs to my mind, for example, data centers, for example. We all hear every other day, and which all of them require much higher data processing capability, and that means the power requirements of those machines are only increasing with every next generation of processes coming through. And again, within defense, there are many other applications that if you can kind of go into each of those application segments, then you will see that the requirements of power is only increasing. So there are lots of other end-use segments that the need for power is increasing, and therefore a good power connector can always help them to optimize the design and make the best use of the technology that they are introducing with a good connector. Yeah.
All right, thank you, Joy, for that answer. So for all our attendees out there, we're going to take one more question today and then start to wrap up. So if you do have any questions for us, feel free to enter those into the window now, and we will reach out to you following today's webinar. And just a reminder to grab those resources out of the resource list. All right, our last question for today, gentlemen. Would you please describe what overload is and why it is important?
So, as I briefly touched upon during in the presentation, so we have come across many applications where, for example, the rated current is 300 amps or 200 amps for sake of argument, but for a period of time, it just requires, let's say, in tenths of seconds. It requires 500 or 600 amps, and that is what we are terming as overload current. What we have seen through some extensive amount of tests is applications that require that sort of tenths of seconds of additional power. That is where connectors really poorly perform because because of the contact resistance, the temperature rise slope is really steep, and as soon as it reaches that safety critical temperature, the derating starts. We have, again, with this Hypertac Green Connect technology, we have managed to demonstrate that in the overload conditions, when you require few tenths of seconds, again, when I say tenths of second, that can be 20, 30 seconds, depending upon ambient conditions and other kind of application-related conditions. We have seen that because this Hypertac Green Connect technology has the lowest contact resistance in comparison to the other peers in the market, the temperature rise slope is really shallow. That means the temperature rise is not as high in comparison to others. So it therefore translates into that you are able to perform that operation for which you need that additional amount of power, if you like, or current. You can operate that machine for that additional tens of seconds longer because you don't have to, or your system doesn't kick in with this derating of the current. So I hope I managed to explain what overload is and why is that important in applications, and what's the consequence, or particularly what's the consequence of where if your temperature is too high, then your derating starts, and therefore you are not able to perform that operation for which you really needed that 500 or 600 amps for tens of seconds. Yeah, thank you.
All right. Thank you so much, Joy, for that last answer. So we are going to start to wrap the webinar up right now. I want to say a huge thank you to Joy and Giacomo for presenting today and for answering a couple of our attendees' questions. So gentlemen, thank you both so much for being here. And thank you to our audience members for being here with us today. Take care, and we will speak with all of you soon.